Hey everyone, Josh Sparrow with Hartfiel Automation here, and today we will be talking about the SICK SIG300. The SICK SIG300, if you have not seen it, is an I/O block with a IODD interpreter that allows for easy setup and viewing of your IO-Link data out of your sensors. It also has a built-in logic editor for simple applications. We'll walk through the setup and go through some of the features and benefits on this video. All right, so now we are into the SIG 300 page. We are programming just on a Chrome browser. You can see I've got an IP address here. That is just for the USB interface. I'm just connected through a USB-C right here on the device. And then we type in this 169.254.0.1, and that is our USB interface. So this pulls up a fresh device that we've got here. Now the first thing that I'm going to do is I'm going to log in under service. The password for this, standard password for this, is service level. All one word, just like that. So I'm going to come into here. It's going to ask me to create a unique password. I'm just going to keep the default. I like the default. For a lot of applications, you may want to change that. You can always change it later as well. So now you can see on my video here that I've got 3 different devices connected up. 2 of these devices are going to be IO-Link, and one of them I'm just going to trigger using a digital output out of the SIG 300. So what we're going to do first is we're going to set up those 2 IO-Link devices. Now I have a CSS high resolution, a color sensor, and then the SLT, the stack light. So I'm going to come into here, and the first thing that we're going to do is come in and load our IODD files. Now if you already have the IODD files off of, say, the SICK website or something, that's awesome. You can use that. Otherwise, a lot of people will use just the IODD Finder website here. If you just search IODD Finder, or if you go to the IO-Link Consortium website, io-link.com, you'll see the IODD Finder link right up here. Now this is really nice because we can put in SICK's name and then we can look for that SLT. Right here, we could download it. Now I've already downloaded it, so I'm just going to come into here and I'm going to find my IODD file management just on the left hand side under application, and we're going to upload this. So I've got this here, we've got the SLT, and then we've got that CSS high resolution. Now you will notice in here that I actually have a Norgren filter regulator in here as well. So at the end of the video, I'll show you how easy it is to hook up non-SICK devices as well. IO-Link is really a great communication because everything should be able to talk pretty seamlessly. The SIG 300 really makes that simple. So we're going to come in here. Now that I've got my IODD files in here, we can set up our 2 devices. So the first thing that we have to do, you see that I've got everything grayed out here. We have to give ourselves access rights. So when you first start this up, everything is given to the PLC so that the PLC can control everything. I'm going to turn off our PLC because for this we're not actually going to connect up. And I'm going to give our UI here access rights to everything. So now I'm able to come in and activate the IO-Link device. I could change this to CSS. And you can see it already grabbed my IODD file off of here. What I'm going to do though is I'm going to change this device identification check. I'm going to change that to yes for a manual, and that gives me the ability to select what version I want to do. Now for this example, we're going to use this IO-Link 1.1 compatible, but we could also use the backup and restore function. If you've got the backup and restore function, you would be able to back up your sensor settings inside of here. And when you plug in a new, in this case, CSS high resolution, it would automatically pull all of the data off of the SIG and into your color sensor. Because we're just doing a demo, I'm not going to set that up, but that's something that we could do pretty easily. So now you can see when I selected the correct IO-Link file, we now have everything set up. It fills in the device ID, it fills in the vendor ID, and then up in the upper right-hand corner, we see the device online. Now, this is the special sauce in the SIG300, is this IODD viewer. The IODD files you can set up inside of here so that you get all of the functionality in the SIG300. You don't have to pull it off into a special software to program. SICK uses SOPUS, so we could pull the sensor off and program it in SOPUS, which I have already done just for briefness of the video. But being able to come in here and see all of the status inside of here, if we wanted to teach in, we could teach in right here. You know, you've got your different settings inside of here. We could teach in different values. So explore this when you're connected up. Know that everything that you're able to do inside of the setting can be set up this way. So what we're looking at here, I've got 3 separate colors here and then the back of our table. So you'll see here when I move this from white to off-white, our QL1 goes from true to false and our QL3 goes from false to true. Same with our green here. Our green is QL2, and then I've got our table set up to be QINT4 down here. So all of that is pre-set up, but we're able to see that live inside of here. And then we're able to really create logic based on that. So let's set up our stack light here quick. Again, we have to give ourselves access rights. So I'm going to set up the access rights here, IO-Link. I'm going to put it in manual, and then I'm going to do our 1.1 compatible, and then I am going to select that SLT. Again, the device ID is set up, the vendor ID is set up. We can come into our IODD viewer, and you can see that we don't really have a whole lot set up here. I'm going to put this into a signal level mode here. And we will be able to see all of the different settings that we have set up. Now again, just like with the color sensor, I've already preset this up. So we've got our white, we've got our green, and we've got a couple of error tiers here. So as soon as we set that up in the logic, we should be good to go. Now I'm going to come back to my access rights. Because I'm going to use the internal logic editor in the SIG, I have to give the logic editor now my process data. I have to do that for our CSS as well. So access rights, write process data, and then in our logic editor. If we don't give that logic editor the access rights here, we will run into issues when we actually go to program this. We won't be able to see it. And then lastly, I've got set up in port 5 here, our event cam. So our event cam is not IO-Link, but I want to be able to just use this inside of here for a digital output. So our pin 4, I want a digital out, and our pin 2, which is what we'll actually use, I want a digital out. Now we're able to then activate the event cam based on that pin 2. So now that we've got our 3 devices set up here, we're going to come back to our application and go into our logic editor. This is where we're able to really bring some of the smarts. The SIG300 makes the IO-Link information really easy to see with that IODD viewer, but we're really able to take this and do a lot of things that a PLC may be able to do. Say we've got a tank level, say we've got an application like this where we just want to be able to know that we put on, say, a label on a package. We want to do some simple counting and everything. You don't necessarily have to pull that into the PLC. We're able to do that right into here. So the first thing I want you to see is all of the different information here. So you can see we've got a bunch of function blocks. This would be for our communication to the PLC. We've got some constants, and then we've got things like S1, QINT3. So like we said, we're using QL1, QL2, QL3, and then I set up that QInt4 as our background table. So I'm going to drag these out, drag them up to the top here, and then I want to take my S5. We don't need pin 4 because we are using pin 2 for that. And then we're going to take our different tiers that we set up from our stack light. Now we're going to take all these, and we can take all 5 of them, which we will use. I'm just going to drag all these up to the top here. Alright, so now that we've dragged all those up to the top, we're going to make some pretty simple logic here. I've got our white color is going to go to our white tier. Got our green color is going to go to our green tier. And then I set up a separate color for, hey, this is not the white that I'm looking for. So I come into here and set that up on tier 3. Now let's just test this out. So we should be able to hit apply. And then on our stack light, as we put in our white, we'll get our white light. As we put in our green, we've got our green light. And then as we put in our wrong color, we get a red light saying, hey, this is incorrect. You can see how close these colors are. It might be tough to tell on the video here, but the color sensor is very robust in what it can see. So now we've got our basic setup, but I want to be able to say, if I have not seen a label, say we've got a green label on a white package, in 3 packages, I want to tell you that there's something wrong. So what we can do is we can come into here and we can go into our application blocks and then in our arithmetic and counter. And then we've just got a counter set up here. And you can see this is a pretty good function block. It explains what everything is. If we hit the little gear icon here, we can actually come in here and see some of the settings that we're able to change. So I want this start value to be 0. I want this to be 3 in a row. That is not correct. And then I want to manually overflow this. Basically, I want it to only start over once I see that green label. So I can come into here. Our white is going to increment it. Our green is going to set this back to 0. And then we have our overflow here. And let's set that up to tier 4. So that overflow, when that is triggered based on this 3 here, we are going to get a signal out to our tier 4. Now we can also set up, say, a delay block here. So we could say, I want to be able to see if maybe we've gotten stuck inside of here. So if we've gotten stuck inside of here, say either the green or the white is there for too long. Maybe in this case we'll just do our green is there for too long. We know that we've got something going on. So we can set up that tier 5. And again, just like with the counter, we can say, hey, I need to see this for, say, 5 seconds. If I see the green for 5 seconds, I know something is wrong inside of there. Now, we also have the output from our event cam inside of here set up on that S5DO2. So what I'm going to do is I'm going to set this up for some digital logic and say, if either of these goes wrong, our counter or our delay, I want you to give an output to our event cam, and then we'll be able to see that as well. Come back over to our stack light, we should see we've got our white light, we've got our green light. If we go back and forth, nothing happens. But if I go white, 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 you can see that my yellow light is now flashing. We can take our hand out, and then we see our green inside of there. We're good to go again. Same with our green. If our green is in there for too long, we know that we've gotten stuck. We're able to put that out. Now, again, with our event cam being triggered, we can actually come back to our event cam on our PC here and see what was going on. So if I come inside of here, you can see I've got these videos right here. If I want to, I can come in, same password that we did before, service and service level, and log in. I'm now able to see what happened here. So you can see, had it set up slightly before, and we were able to then see what happened inside of the process. All of that is set up straight through here, and then all of your logic is saved inside of here. So very easy to set this up. This has been a pretty simple application, but we have customers using these for packaging machines, for level filling rooms, for all sorts of different things. There's a lot of different logic inside of here that you can come through and explore. And we can even convert out to those function blocks so that you're able to pass this data that you've got inside of here out to your PLC. If you wanted to pass the counts out of here, you would be able to do that. So the last thing that I want to show you here is actually plugging in a non-SICK device. So I'm going to come in and plug this into port 3. And here I've got a Norgren filter regulator. And I'm going to plug this in. And right here, you can see that I've got power on here. We've got some pressure coming across. And so I want to do the same exact thing that we did for the SICK sensors. The first thing I'm going to do is come into that IODD file management. Again, if we went into the IO-Link Consortium IODD file, you can see we've got Norgren, and then we've got all of their products inside of here as well. I've already got this downloaded, so I'm going to come inside of here. We can come into here and connect this. And then in our port 3, give ourselves access rights again. We're going to give that to the UI. And then our port 3 IO-Link. You can see it already found it. And because I'm not using it in the logic editor, I don't necessarily need to change it to that manual. And now we're able to see all of this inside of here. If we wanted to change our pressure settings, if we wanted to change the display on the front, anything like that, we're able to do that right inside of the SIG. It does not matter which IO-Link device from what company you're using, that IODD file will be right in there so that you're able to very easily go grab that and pull it into here.